Sound check. Perfect. Welcome, everybody. Please have a seat. Let's make this as informal as we can. And welcome to this workshop on trusted and responsible AI in practice. So what we really want to do today with you guys is to start with a real-life use case, which is a job matching application, and then using the trusted and responsible AI best practices and, of course, the Microsoft toolings, see how we can really improve it, rebuild it in a better way, and definitely make it more scalable and reliable in the future. So today, I'm already having tech issues. There you go. My name is Joël van Damme. I'm a senior manager in data science and AI at EY Belgium. And I'm sharing the stage today with Mick and Harmke, two of my amazing colleagues from Microsoft, both cloud solution architects with a focus on AI. So what we want to do today is start with a use case, real-life use case, not something that we've built ourselves, but use this use case actually as a common thread to really apply the principles of responsible AI and then actually put all those knowledge into practice to see how we can use this use case and rebuild it in a better, most transparent and reliable way. We want to make this interactive, of course. Please save your questions for the end. Mick, Harmke, and myself, we're not going anywhere. We're going to stick a bit to the stage. We're also going to be present at the EY booth. So if you have questions, if you want to follow up on some discussion points, don't hesitate to connect with us. And most importantly, we're also going to ask questions. We also know it's very close to lunchtime. We want you guys to keep engaged and enthusiastic about it. So we're going to use the Vivox app. So you don't actually need the app. You can also use the browser version. If you just type vivox.app on your phone and you join the conference, which is surprisingly called World Summit AI. If you type in these numbers, I know it's a bit small maybe for the back, so it's 134-257-111, and then the questions will pop up on your phone, and then you can answer as they come. All right? So let's start with the use case itself. So the use case that we're going to use is actually a job matching application. So it's pretty simple in concept. You put your CV in, you upload it to our website, and then you get matching results of which job you can actually get based on your resume. And so those matching, you have percentages to give you a bit the quality of the match that you have for the certain jobs. You have some color coding also to help you visualize it in a better way. So it's pretty simple. And that's actually something that was built by a public servicing agency. So their idea was, if I put something like that and give it to the public, people can actually have a better shot at employment or identifying where they need to upskill themselves. So that's the context, but I'm sure you can think of other applications, whether it's for fostering mobility within your teams, identifying maybe redundancy of skills. So a lot of different applications relying on the same technology. We can certainly have a lot of ideas. And I have to say, from a tech perspective, they did quite a good job. So they built this as a web service. They had their own website and dedicated website to host it. It was entirely cloud-based. And they also put a lot of effort in the AI behind the screen. So they have a very intense pre-processing pipeline, for instance, to translate CVs, to remove objects from the CVs, to also pseudonymize it as well, removing all the unnecessary information. And they also had a very intense custom language models that they built to really make sure that the matching was done based on skills and no other information, and that they could also have a vocabulary that was rich enough to cover many, many use cases. So quite nicely done. And so my first question to you guys, based on this, if you look at this, what do you think could possibly go wrong with an application like that? So in terms of risk, in terms of access, in terms of way of working, go to your phone. The Vivox app, the app ID is on the left, so it's 134-257-111. I see some responses coming in. Shoot out. What would you say could go wrong with an application like this? I'll give it a couple of seconds. All right, some activity. When you reach magic number 20, I'll close the poll. All right. So let's see a bit. Oh, it's not even starting. It's way too enthusiastic. All right. So I'm not sure if you can actually read from the back, but I see a lot of people. This is the word cloud, of course. Couldn't help myself. A lot of people talked about bias, inequality. So those are more about the quality and the potential drifts. Gaming the systems, that's definitely more about the user. Privacy, big one. Data leak, gender bias, missing the mark. So actually, you gave quite a lot of nice answers, and we're pessimistic as well. So this is actually what went wrong when we put ourselves in the shoes of the users and did some tests. And you started off relatively okay. So if you put a manager, data scientist, 15 years of experience, you get matched with a commercial collaborator. Bit of a stretch, but why not? If you're a junior data scientist, you should definitely go for a receptionist job, apparently. Then you start putting random text about birds or stuff in Latin, you still get matched with potential jobs that you should get. And even more worrying, if you put the same CVs and you just change your name, you get different results in upskilling. So for everybody that discussed about the quality of the matching, indeed, we can probably do better. And on top of the functioning of the application, we also had different concerns. So if you put actually the training data in the application running in production, you would get different results than the original one. And there was absolutely no monitoring of the application, so you had no idea who's using it, how many requests it handles a day, if it's up and down, actually, still no clue. And also, no information whatsoever from the user about the existence of an AI-powered system. So as a user, you have no idea how those results are actually generated, which of course is kind of an issue. And so what this does is actually highlighting how difficult it is to build skilled and build trust in an AI application in production. And so that's why we have at EY the Trusted AI framework to really emphasize on those aspects. So I know it's pretty small, so I'm trying to walk you through it. But the idea behind this visual is to say if you want to build a reliable AI system, and by reliable I mean unbiased, resilient, explainable, transparent, and performant, you actually have to be very mindful of the risks that you actually are exposing yourself to. And those risks come throughout the whole cycle of development of an AI application. Starting with the problem identification. You have risks that come from the design. Is my application fit for my purpose? Is it going to do what I need to do and nothing more? Then you have all the risk about the data. Is the data that I'm feeding in qualitative enough? Big enough? Do I have bias? Do I have issues in the historical data that I use that I haven't managed? Then you have the risk about the algorithm that you're going to use. Am I going for something that's particularly greedy but will fail on the corner cases? That's also a big one. And then you have all the risk about performance. Will this still be performant over time? Will I need to retrain it? How will I spot the need for training? So we actually translate that back to my junior data scientist who was matched as a receptionist. Most likely, when identifying the problem, they failed to think, do I want to also address those specific, very technical jobs? Or do I need to build a different model for people with less than 2 years of experience? That would have been a way to mitigate that specific risk. In the data preparation, they use mostly the current job openings that they have. And most likely, they didn't have many job openings for junior data scientists. So actually, using a data augmentation procedure or relying on other data sources or maybe creating some synthetic samples would have helped mitigating that risk as well. Algorithm. My bet is they went for high recall because they wanted to give a high coverage, many people getting new jobs and upskilling. But in this case, then we failed to address the corner cases. And last but not least, the performance. We've seen it. If we put some things that are a little bit unexpected or different than or the original data, we get surprising results. And so all this really puts the focus on the fact that you really need to seek for those risks and addresses and tackle them with all the stakeholders and all the governing processes to make sure that you can actually achieve what we call trusted AI. Now back to your phones. Because we're going to rebuild it, but of course, I know we have a lot of developers in the room, so let's use your knowledge as well. Which tools, techniques, ideas do you think we can actually use for this specific use case to make it a bit more robust, a bit more efficient, transparent? What have you used in the past that you think we can actually use to make this one better? I see responses coming in. And you can go as far as you can. It can be tools. It doesn't have to be something very specific, just ideas based on what you've seen, what would already make it better. All right. Let's close the poll. All right, so human, that's for sure. So definitely in the way they design the application, they are missing a bit that human touch and that business knowledge. Transparency. NLP, working on the NLP component indeed would have been a way to help. And MLOps and Azure. That's actually a very good transition to my next slide. So let's see a bit how our colleagues from Microsoft have incorporated those concepts into their product development. Mick?
Yes, thank you. Am I on? No. Test? Yeah, thanks. Yeah, so before we dive into what kind of tooling we have available at Microsoft, I first want to start with what we actually are doing at Microsoft on this topic. Okay, so when we talk at Microsoft about AI, we also talk about democratize AI. And what our mission is to make AI available to everyone. So every organization, every person, we want them to be able to work with AI. You don't need to be a data scientist to work with AI. But this also brings other responsibilities to us. So I want to talk a bit about what kind of responsibilities does a technology provider like Microsoft have? And what kind of responsibilities do you have as an individual or as a company? And what we strive for at Microsoft is human parity. And with human parity, in short, we mean that a human and an AI model, when they do the same test, that they reach the same level. And in this sense, we at Microsoft, we already achieved human parity for many of the different pillars in the last years. And we have over 10 research centers all over the world. Even one of them in Amsterdam in the coming months. And our research professor is also speaking. I think he has the end keynote today. But this is something that we see a lot. And we strive for human parity, but that also brings new concerns. Because when an AI model performs the same as a human, and especially what we see nowadays, with, for example, OpenAI, and with the bigger language models, all the models are getting bigger and bigger, and we have natural language generation, that a model can create prompts that you can give it input, and it will just generate how a human will generate it. And all those new technologies, all those new, let's say AI models, they also bring new risks, and they also shift some of the responsibilities. So for example, when Microsoft will provide something like this, there's a lot of responsibility on the side of Microsoft, that we train it in the right way, that we have governance, that we only use the right data. And that also brings me to our AI platform, because I'm not going to discuss this in detail. If you want more details, you can always come to us later, because I can talk a few hours about this. But one of the key things that we do at Microsoft is we try to make it available to everyone. So we have developers and data scientists, maybe the majority in the room, but we have a platform that can deliver value to them. So we have Azure Machine Learning, and we're going to demo that later. But Azure Machine Learning is our platform where you can run Python, R, and do the full end-to-end cycle with machine learning operations, with responsible AI, with a lot of other things. The whole training cycle you can do in this platform. But something else that we offer, and that's more focused on developers, is our cognitive services and our scenario-based services. And this is our platform. You should see it as a web API. It are just simple web services that you can consume pay as you go. You don't have to do a huge investment up front. You just say, I want, for example, OCR, or I want like entity recognition, and you can just buy or purchase that from us and use it pay as you go. But that also brings some of the responsibility back to Microsoft. We need to make sure that all the models that we train, that everything is governed, and that we use the responsible AI process. And in order to have that, at Microsoft, we have, for example, the Responsible AI Committee, we have the Office of Responsible AI, and we have a lot of those committees that are core of our company. So for every product team that wants to release something, they have to go through all these committees, and that's something I will come back to later. But as said, we strive for human parity. And one of the examples where we reached human parity a while ago already is text-to-speech. And I would like to see with the audience, like, if we discuss text-to-speech, are you still able to see the difference between a synthesized voice, so a voice that's made by the computer, and a voice that's created by recorded by the human? So I'm going to show you two audio samples, and I would like to understand if you still know which one is the human. So I'm going to start with the one on the left, so the first audio sample.
You can't know how long Tara would have been mad because that was taken away from her.
Okay, so that's one.
Can't know how long Tara would have been mad because that was taken away from her.
Okay, let's do them once again. So 1, first?
You can't know how long Tara would have been mad because that was taken away from her.
And the second?
Can't know how long Tara would have been mad because that was taken away from her.
Okay, so let's see which one is the AI voice, which one is the synthesized voice. Who thinks that the first one is the robot, like the AI voice? Can I see hands? Is this a majority? Half? Yeah, I think a bit more than half of it. Who thinks it's the second one? I would say the other ones. Oh, only a few people. No one dares anymore. But you were right, indeed. The first one was the synthesized voice. The second one was the recorded voice. So let's try it once again.
The forecast for next week shows sunshine with highs in the mid-40s.
And the second?
The forecast for next week shows sunshine with highs in the mid-40s.
Okay. So who thinks that number 3, so the first one, is a synthesized voice, is an AI voice? Okay, a few hands. Who thinks it's the second one? I would say the other ones. So in this case, the audience is partly wrong, because the first one was actually the computer voice. And how I could spot it, because I've done this demo a lot of times, the thing is as well, like, the first voice is like very perfect, like there's no pausing, everything is like very, maybe not natural, while the second one, they are pausing a bit more, and maybe for native speakers, I'm not a native speaker, so I cannot say that, but that's a bit how they do it. But what you see here is that it's getting pretty close, and next to this, we also offer custom speech, custom voice, which means that you can train it with your own voice. And of course, I think we're all aware about deepfakes and all those other things, and this is very dangerous. But we have this technology. And this is something that we try to solve at Microsoft as well in another way. So what we added together with the committee was a gating process. So for all this kind of services where we're not sure if people will use it responsibly, we add the gating process. People can only use this technology if we approve it. So first they have to fill in a whole form. Only companies and individuals that are vetted can do it. And they have to say, hey, this is my use case. The voice talent has also to say a few sentences so we are sure that you're just not using someone's voice without permission. There are really very, let's say, strict sentences that you need to use to validate. And if it's approved, a certain company or individual can use this service. So that's what we try to add, because we think it's our responsibility to make sure that this kind of technology is public and accessible, but as well in a responsible and in a safe way. And I can talk a lot of nice things about it, but there are also a lot of developments there, because even as a Microsoft and as in the community, things change. So on the left side, you see our Face API. And we have our Face API already for, I think, more than 5 years, since I joined Microsoft. But we had emotion there, gender, age. And I think everyone is aware of the public debate. Gender is not something that you can see on a person. Like, we cannot say someone's gender based on the picture. How can AI do that? And same for if you look at emotions or if you look at age. It's not something that we can just decide based on what we see. In every culture, for every race, it can be different. So this year at Microsoft, we said, okay, we have these API, we have these capabilities, but we are going to deprecate it immediately. New customers cannot use it anymore. For other customers, we are going to sunset it in a responsible time. And we only support face verification, so that you can say it's a face yes or no. So we can have that detection. And even for that, we added a gating process, because we want to make sure people use it responsibly. So there's a lot of developments there as well. And as well on OpenAI, I already mentioned it before. Microsoft and OpenAI have a partnership. And OpenAI, if you're not aware, they're a technology company or an AI company that have GPT-3, DALL-E, and a lot of those transformer-based models that are very innovative and that they are releasing bit by bit to the market. But there are also like a lot of concerns, because if you think about, for example, GPT-3 with language generation, there's a lot of harm that can be done there. Same with DALL-E. If you can generate images based on a prompt, there are things maybe that you can do that are not responsible. And that's also why we're partnering with them to try to make an Azure OpenAI service that on our cloud, that we have a service that's using their models, but where we have a lot of safeguards so that we can make sure that companies that want to use it in a responsible way, that they can use all the innovation from OpenAI on a trusted enterprise cloud like Microsoft with all the safeguards in place, so that prompts are filtered before, that the output is filtered, that there are a lot of safeguards there. But this is an ongoing debate and discussion, because things change. Regulations will change, hopefully. There will be more like public debate about it. And as you see as well with the Face API, we start with something, but in the end, maybe it's not the right thing. And that's, I think, where we're all responsible for. And that also brings me to the next one, because does someone know what we're seeing here? And you can just shout, sorry, I'm not walking around with the microphone. Yeah, but so I will repeat it. But it's indeed a soccer field, but the thing what you mentioned is indeed the case. They had it's a Scottish soccer team, and they had a camera that could follow the ball. And it's pretty cool because you don't need an operator, it can just follow the ball. But then they added the linesman, and the linesman was bald in this case. And you can imagine someone that's bald and a ball, it has some similarity. So it's just following the linesman all the time. And yeah, the thing is how to mitigate risk, because at Microsoft we do a lot of these things and we try to prevent bias and all the things when we train our models. But as a company or an individual, and when you train your own models, it's mainly your responsibility next to the use case. So how can you mitigate this kind of risk? Because in this case, it's not really hurting the linesman, or he's a bit more, or she is a bit more on camera. But there are a lot of scenarios that can actually hurt people or do harm to people in another way. So what we want to discuss and demo as well today is how Azure Machine Learning, our platform to train machine learning models, how we have some kind of tools there to help you in this process and to make it easier to tackle some of the responsible AI scenarios. And Joël already discussed it in the beginning with the whole framework. I want to highlight a few elements of that framework and especially about how to detect it. So we will start with Identify. And with Identify as a data scientist, for example, what you can do is you can see like, how's the model performing? Like within the data, is there a cluster of data where the model is not performing for? So to identify, is there an issue? Then as a next step, we will go to diagnose. So really understand for this particular group of data, what is the actual issue? Is it like not balanced, or are there other features that are not right? So really understanding what is the issue. And then as a last step, we will see how can we mitigate it? How can we make sure that we remove the bias or fix something else so that in the end our use case is solid and that we can go to production. Because if you didn't tick all the boxes, you can never go to production because you don't have responsible use case and you don't want to have it in production. So I can talk a lot more about this, but let's just do a demo. And please, Harmke, come to the stage and show us the cool things.
Yes, hello everyone. So for the next part of this workshop, indeed, we will look at a very practical example on how you can implement some of these analyses and mitigations to see how responsible your model currently is and how you can improve it. Very practical example. So the scenario that we will look at is very similar to the one that Joël mentioned in the beginning of the presentation. It's not exactly CV matching, but what we will do is to train a binary classification model, basically to predict which job candidates should be invited for an interview. So in this scenario, imagine that I'm a data scientist, and in this case, I'm a data scientist working on Azure Machine Learning, and I'm working on developing this model. So I will first walk you through the process of how this model is developed, and then we will take it to the next stage to see how our model is doing in terms of the responsible AI metrics that we will be calculating. So I know that the screen is a bit small, that not everyone will be able to read what we see here on the slides. Oh, the screen is not switching, by the way. 1 second. Mick, do you know? Oh yeah, that's better. Thanks. So that's better. Now we see the interface of Azure Machine Learning. Maybe you are familiar with it, maybe not. But this is a platform that can be used by data scientists to build their own machine learning models. And what we are now looking at is a Jupyter Notebook interface where I can use Python basically to do the training process. So what you see here in the first couple of cells in my notebook is that I start with some setup and preparation. I'm just installing some libraries here and setting some variables here. And the step right after that is that we will start accessing the data that we will be working with. So the data is first in a local folder, and from there we will load it so we can display it in our notebook. And I hope that the data is a little bit visible in the back as well. But just as a summary, we have a tabular data set and a variable, a target variable, where we want to train our model on, and it's called hired. So this basically indicates, based on a historical data set, whether a programmer who applied for an open position previously was hired or not. And then we also have some characteristics on these programmers. So for example, what is their favorite operating system? What is the development platform that they like to use? Is that Visual Studio Code? Or is it maybe PyCharm? We also have their favorite programming languages and also some more sensitive variables like their gender and their age. So based on all this information, we will start training our model. We will first connect to our machine learning workspace so we can also register our currently local data set to our workspace. And we are doing this also to make the model more responsible in a way, because we are tracking and storing our assets, so we know which version of the data set we use to train our model on. So that's what we are doing right here. And from there, basically, the next step is to start training a model. We have our training code right here. I will not go through all of it in detail, but we are just training a simple decision tree model on our data set, on the different features that we have in our tabular data set. And then the code gets a little bit more complex because we will run it as a pipeline, and this helps us also with the more graphical experience of what our pipeline looks like. I will show it later. And then basically here we will have our running pipeline. That's here. I will not run it right now because it will take some time. But what I will show you is what the pipeline actually looks like that I just generated. So we have some different components here. We start, of course, with our training data sets. From there, we have a step where we are training our model. And the last step is to register our model to our workspace. So that's basically all we need to train our machine learning model. So now what we have is a binary classification model that, based on new information from programmers that are applying to our open vacancy, it can basically give an estimation of should we invite them for an interview or not. And now maybe as a data scientist, I could say, okay, maybe my job here is done. I trained my model. Let's see how we can deploy it. But now we're taking it to the next step. Because what we will do is that we will also use some of the tools in Azure Machine Learning to create responsible AI insights and to see how our model is doing. So that's the next step. We will load some of the components that we need to generate these insights. So we will create another pipeline here. We will also create a definition of a scorecard. You will see later where we need this for, but this is basically to also create a summary of how our model is doing for more of the compliance side of the house. Then we generate our pipeline again, so we have this graphical representation of all the steps that we're taking for our model. And then all we need to do is to run our job. And then what this looks like when we have a look at the pipeline is what you see here. So we will have some more steps than we had for our training pipeline, because this time the input that we need for our pipeline is not only the model that we have trained. Of course, we need that to generate our insights, but also the training data and the testing data to basically do the experiments and the analysis that we need to generate the insights. We are using some of the components here. You will see them popping up later in the dashboard. So like creating the explainability, creating a causal analysis, and eventually all those insights will be collected into one single responsible AI dashboard. So we will now have a look on what the responsible AI dashboard looks like. And it's good to know that these dashboards can be automatically generated for a new model that you will be registering. So that's another advantage of these different components that we have. It's a good practice to automate the responsible AI insights. So we can make sure that we're including these principles in all the models that we train and the steps that we take. And let's have a look now at our data set. So this is our dashboard. We have some different components here. The first one is an error analysis. And what you see here on the screen is like a tree type of structure based on the test data set that we have. So our full test data set contains 800 examples. So these are all examples of programmers that the model didn't see before when it was training. So all new examples. And what we can see here is where in this test data set most of the errors are located. And this is important because, of course, we want to know if there's a certain bias in the model, if there are certain groups for which the model is not performing as well as for the other groups. And in this dashboard, this is represented by the color that you see in the node. Maybe you cannot read all these numbers specifically, but at least in terms of colors, we see that on the left side, it's a little bit more gray, and on the right side, we have most of our errors because it's more red and even dark red in one of our nodes here. And what we can see is that for this group specifically, the error rate is 55%, which is quite high. So in this case, it would be important to look at what are the features that lead to this high error rate and how can we prevent this from happening. And when we click on this node, we see that this is a group with years of experience more than 11 and a half. The gender is set to male, and the age is less than 30. And it's good to know, by the way, that all this data is synthetically generated, so please don't take any conclusions from what you see here. But based on this high error rate and this group that we just selected, we can create a new cohort in our dashboard. So this would be the smaller group that we have just selected. We can give it a specific name, like the male years of experience is more than 11.5. We can save this as a new cohort in our data set, and let's have a look at the other widgets that we have in our dashboard. So the next one is a model overview. And what we see in our model overview is that we can compare the performance of the model in general. So on all the data, the full test set, we can compare that to the cohort that we have just selected. And what you can see here is already what we have concluded, that the accuracy is lower on the smaller group that we have. But we can also see here, for example, that the selection rate is quite high, and that we have a lot of false positives in this group. So this could lead to, or this could be an indication that there might be a bias in the model towards one or more of the characteristics that we have in this group. So that could be an interesting start of further analysis and to see how we can improve our model there. Another widget that I would like to highlight is the feature importances. And this one is also based on both the full data and on the subgroups. So in general, it's always interesting to look at these feature importances because, of course, we want to know when we have trained our model which features are most important to lead to a certain outcome. And we can see here that in the top 4 that we already see the gender feature popping up. So this could be something to think about. Is this a feature that we want to include in our training process? Or do we want this feature to be so important in defining the outcome of who should be invited for an interview in this case? And what we can also see that for our specific group, so the smaller group that we have selected where the accuracy is lower, that's the purple one that you see here. The gender is even more important. We're getting some different signs here that for this specific group, that the fact that these are male candidates are an important factor in selecting them to be hired for interviews. So that is definitely something to look at further. And then the last widget to highlight here, so far we only looked at metrics that look at the data set as a whole or to a smaller group of the data set. But what we can also do is looking at specific data points, and that is what we call here a what-if analysis. So we select here one data point and we create our analysis. And what we can do based on knowing that for this data point our model predicted that this person should not be invited for the interview, and some similar data points that we see right here that have slightly different values, we can experiment on which values would lead to a different outcome. So it's an interesting experiment to do. That's what we see here. So what we know from this data point is that the gender that we currently have in our data set is other or unknown. And we can change it here to the male gender. And what will change is that you see here that the predicted value based on our model would change from a 0 to a 1. So this is also an interesting analysis that you can do on individual data points rather than groups. So these are some of the widgets. It's good to know that other widgets are available here as well, but these are just the widgets that were interesting to highlight in this case. And it's also good to know that this is just where the process of building a more responsible model starts, because now we did some analysis, we have some diagnoses, and maybe we have already our conclusions on specific features that we want to exclude or maybe that we should add for our data set. But from here, it basically starts in mitigating and making sure that your model gets more responsible over time. So this could be part of the job role as a data scientist. So now moving to the last part of the responsible AI process, because of course it's not only for the data scientists to worry about this topic. What we also have generated in our pipeline is something that we called a scorecard. This can be defined on certain metrics that are interesting for the use case, but this generates a PDF summary of how our model is doing, and this could be sent, could be implemented in a compliance process, for example, to make sure that that multiple people in the organization are involved in making sure that the models that are used are responsible. So what we see here, for example, is the performance of our model. We see a confusion matrix of how the model is doing on a test set, but we can also look at more sensitive features, like we see again the gender popping up here, and you would see for the different for the different values that we have for this feature, how is the performance of the model different for these subgroups. So this is also something interesting to look at. And with that, I would like to hand it over again to Joël.
Thanks, Hanke. All right. Now, that was very interesting and very impressive. And some of you might still be relatively new to the cloud journey or not familiar with the Microsoft toolings. So there's also, for those people, a plug-and-play option. And that's something called Shazam, which is something that we actually have developed with Microsoft. And it's a fairness as a service, if you will. So the idea is that we've built a modern data platform, so you retrieve everything that you would expect from a data platform, from data ops, data feeding pipelines, an integration with your code versioning tools, your data versioning tools, integrated CI/CD, MLOps operation, but with a twist. And the twist is, behind and across all those functions, you also have fairness analysis and fairness functions that were built in. So counterfactual what-ifs, like we just saw, drift analysis, bias analysis, automated splitting of your cohorts into different groups based on certain variables, and also the option of automated the retraining of your models if some of the variables that you're currently using are not usable in a trusted and responsible way. And this is a bit what we see. So this is the basic idea of the platform. And so for each step, from model development to validation, to deployment and monitoring, you actually have a support to automate and validate everything you do based on industry standards, also automating the documentation and for different stakeholders and different audiences. So you would have a differentiated documentation for the data scientists if they need to review their choice of data or features, but also for compliance and risk. They would also have dedicated reporting. And so all these you can actually do and use as a support for all your experiments and all the models that you're currently using. So also very, very interesting one. All right, now we discussed tooling, we discussed theory, we discussed framework. What now? So it's going to be the last VVox of the day, so make it count. But after seeing all this, hearing all this, where do you think, what is still missing? So which hurdles do you see in your daily lives, in the way you currently operate today, that will still prevent you to be fully autonomous and as far as you would like to go when it comes to responsible AI and achieving trusted and responsible development? And it's really open. We're going to have some time for questions as well, so shoot. Whatever you think is still missing or mystery, give me what you have.
Those new paradigms, we will look at better systems. We will not look at just replacing a recruitment process with a lot of lists of CVs, and we will say, well, why did that person didn't have a job in the
All right, let's give it a couple of seconds more.
We will look for other indicators that will more predict flexibility, adaptability, and that quotient, and Marijn talked about more indicators before as well. I think that will help us a lot in learning, eventually,
All right.
how we can make sure that we attract new talent, that talent value, but also that the selection process is
A lot of unknown. All right. Well, I'll try to address the unknown in the Q&A or at the booth, no problem. Priorities, that's definitely a big one. It has to be a choice. When designing your AI roadmap or your data roadmap, you have to make it a top priority to also address the trust and responsible issue. Actually, if you don't, you're going to have such a huge debt that's going to be very costly, budget, to get back to a state that is acceptable for everybody. Not enough data, that's a big one. But again, there are a lot of progress that's being made on how to generate synthetic data or having a sound data augmentation strategy. So that's also something that's very available. And unbiased data, that's definitely a big one. We cannot ignore the fact that a lot of the data that we use, especially historical data, have bias in it. So a prerequisite in any case would be make that conscious choice and effort to look for bias in the data, correct it, address it, and only then use it for feeding new models. Overall, I think a lot of stuff that we discuss is coming to the fact that operating a trust and AI program would be just like operating any other robust AI program. And you start by assessing your current state. So what do I have today in terms of assets, in terms of people, in terms of resources that I can already base myself on? So it's about where do you see yourself in terms of maturity, but also in terms of assets that you might have. Not everything is necessarily in-house, but you can also find them out in unexpected places. So starting with step one, what do I have at my disposal and what my strategy? Because just like for any other AI roadmap, the trusted AI roadmap has to fit with your strategy. And hopefully your strategy is to go toward more trusted, responsible, and transparent AI. And then comes the second step, the design. And this is where you actually make the gap to where you want to go. So it's starting with defining the policies, the standards, the procedures that you see now are lacking for you to operate this program, but also make sure that you have the checklist, that you challenge what you already have, that you make sure to get sufficient help also, and inputs for different stakeholders within your organization who are going to have a critical look at what you're doing and will help you also tailor your approach to make sure that you address their issues as well as your own as developers. Training and awareness. A lot of the stuff that we discussed today is supposedly known and yet still not in place. So somehow there's a bridge to be done here between the current status, the to be, and what we think we already know. That's a big one. And then finally, it's about getting that information, that trust, and this theory up into the advisory board. So Trusted AI program is something that should travel across the organization to make sure that everybody at each level is conscious that this is a choice we're making, this is how it's going to impact the way we develop, the way we recruit people, the way we train our people, and this is how it translates into actions. And last but not least, once all this is defined, you actually operate what we would call a Trusted AI program. Now, I know there was a lot of information, so important to know we'll also be at the booth. So if you want to discuss any aspect of this roadmap or the slides that we discussed before, the toolings, feel free to come. But this is a bit what we had in store today, and actually with some time to spare. So thanks, everybody, for coming today. You can actually scan the QR code if you want to have a copy of the slides, and you can just download it. So I'll leave it here. But yeah, thanks a lot for participating to this, and don't hesitate to come back to us if you have any questions. Any team? Actually, we have still some time, so if you're not too hurried for lunch, we can pass around the mic and you can ask your questions to me or my colleagues. Don't be shy.